Hi, in this video we'll talk about a problem set question related to Archimedes and also density. If you haven't checked out the video from EdTech about Archimedes, I'll put the link in the description below. Make sure you watch it first before you proceed our video here.
A few moments later.
Alright, so I hope you enjoyed the video from EdTech. This is how Archimedes got so famous by the word Eureka, and also the fact that he was naked when he just ran out from the bath. So here are two questions related to density, and I want you to spend some time to do it first, and we'll check out the answers later on. So pause the video now and do it first.
2,000 years later.
Okay, because of the time, I already finished writing up the answers on my screen. So it's very straightforward actually. So for question 1, you just have to use the equation of density equals to mass over volume. Remember, you have to memorize this equation in IGCSE physics. And so for each of the crown, A, B, C, you just have to substitute its mass and volume into it and find out the number. The density is actually given. So just to remind you once again that for density, it depends on the material itself. It doesn't matter what mass or what volume you're having, as long as the material itself is a pure material that is making that particular object. So for A, obviously this is silver, which is kind of lighter if you have the same volume, if you compare that to gold. And the second one is obviously gold, and the last one is between gold and silver, is around 11.9, so it's a mixture of both. In fact, you can use a mathematical weighted formula to find out the ratio of the gold and silver of crown C. So if you know how to do it, show me in the comment section and let's see if your answer is correct. For question number 2, is similar to what you did in the previous video about how you can calculate the density. Remember, you cannot measure density directly. You can only calculate density because there's no machine or instrument to find out and measure density directly. So you can only do it by measuring the mass and the volume first. Anyway, so here for mass is simply you can see 90 and 170 here. So don't get fooled. Here is not 0, so that's why you need to do the minus, and therefore you get 80 grams for the liquid. So ml refers to mass of the liquid. VL, the liquid volume, would be 100 because there's nothing here. So if you like, you can do 100 minus 0 is fine too. But then I'll just write down 100 cm cube. Don't forget to put down the unit. Lastly, rho L would equal to mass over volume. So if you can write the equation, that would be nice. So that would be 80 grams over 100 cm cube. So that simply be 0.8 gram per cm cube. If you like to use not the fraction, use it negative, that's fine as well, right? Both of these will be accepted in IGCSE physics. For part B, it will be extremely similar, and I'm pretty sure you know how to do it. So I guess you can just check the answer. 120 gram and 48 cm cube. You can do it by minus from the previous stage, and lastly you just divide these two to get the answer, which is the density of the rock. Alright, because as you can see the video is now only 4 minutes, so I think it's better to just combine the questions from by the end, like this 1, 2 and these interesting questions in this video as well, instead of making a separate one. So please take your time, pause the video and try out this question first.
A few moments later.
Alright, first question, and by the way, these two questions are actually from the IGCSE past paper, by the way. So this is a measuring cylinder, obviously, and if you recall what we learned in the previous video, we have to pay attention to the parallax error, and also we have to read from at the bottom of the meniscus. Alright, that means the curvature of the surface here. So that means it should be this level, right? In fact, it is not really touching this one. So this is 30, this is 20, so I guess this is 22 because this is 1, 2, 3, 4. Oh, actually that is 25, and this is 27.5. So this might be 28. Yeah, 28 I think is the best answer, because it cannot be 24, it cannot be 29. 29 will be something like this. Alright, it will be something like this. So not yet 29. Alright, next question. So here you can see there's a pivot, and x and y from the diagram, they are of different volume. So you can have x volume and y volume, and the y office is just bigger. You can just see it from the diagram. And the thing is, the question asks you about the relationship between x and y. So let's just see. They have the same mass and same density. Same mass, I would say yes, because imagine instead of like these two, because this is supposed to be in the center, I suppose, right? The question actually didn't say that, but I suppose say this is 1 meter, this is also 1 meter, because the length actually matter. You'll get to learn this in the chapter 3 later on in IGCSE. So it's not really a good question. I would say they should specify this, but let's say it's equal distance, and so the most important thing is then is their mass will be the same. So let's say this is 2 kg, then this should also be 2 kg, no matter what size they are, right? Because the reason why you can balance the beam like the seesaw, I'm not sure if you play that in the playground, is all about the mass, not the volume. So mass is the same, of course, but then density cannot be the same because they are of different volume. Again, density equals to mass over volume. So if they have the same mass but different volume, then they cannot have the same density. Option B, same mass, yes. Same weight, yes. All right. In the later chapter, you will get to learn that weight is a force, and that is calculated by mass times gravity. More precisely, gravitational acceleration. So B should be the correct answer. If you don't know what weight is, maybe you can see what happened to C and D. Maybe you can do it by elimination. So again, density is wrong, and D, well actually, when you say same volume, is already wrong. So the answer is obvious, B. For the last question, if you don't know what that is, then I guess you can firstly observe what happened first. So in the picture, it is Coke Zero and the traditional normal Coca-Cola. And in this video, it's the same. It's just the package changed to white. So it's also Diet Coke and also the normal Coca-Cola. So the most important thing is you find out the normal one will actually sink, while the Diet Coke or Coke Zero will actually be floating. So my question is, why? Why is that? By the way, I wonder what happened to other soft drinks. So if you have other soft drinks at home, please try out this experiment by yourself and tell us your result and finding in the comment section below. Since I don't have the two soft drinks in hand as well as the electronic balance, I can't really do the measurement. If you have one, please help me to do a measurement and tell me what you find out. So I can only rely on this reference, and this reference told me that for the Coke, which is mainly containing water with 325 ml, which is cm cube, it also contains 39 grams of sugar. So in total, that's gonna be about 364 grams. So the sugar actually contribute about 10% or more than 10%. I think it's more like 11% of the mass extra on top of the water. So that's why the density will get much higher than the water itself, because remember in the video we saw that, or in the picture we saw that this one will actually sink. So that's because the density of the traditional Coke is going to be denser than the water, which is the liquid here. So that's why it will sink. And so for the Diet Coke, because it only contains like 0.3 grams of some sort of like sugar replacement, I suppose, like I don't even know what this chemical is, and therefore most of its content is just simply the water right inside. So 355 grams roughly, and so that will make its density to be very close to water, which is still 1.00, so very close to water, and therefore it is able to float on the top of the water. And so for the Coke, it would not, because the density is just slightly higher than the water itself. And that is all for chapter 1. So in this chapter we have learned about the prefix first of all, and then we learn about the measurement for the length, for the time, for the mass briefly, and also for the volume, and we also talk about the idea of density. Lastly, I would strongly recommend you to think of a meme that is related to this chapter, and I want you to submit it with the QR code or the link at the top. If you want to do that, I'll recommend you go for the meme generator. You just have to type it on Google and you can find this website. So you can then use different meme templates to create interesting meme based on what you learn in physics in this chapter. You can find out more templates by going through this page as well. Okay, and you can just simply click into it and caption this meme, and you can then type something. Okay, so I will look forward to seeing your memes submission.